Right. So we got to get all our ducks in a row. So, all right, there's our, so my favorite number is 0, right? So you want to think about what is the list with 0 elements in it, right? Yeah. Yeah, exactly. All right. So if it has a few elements, then the last record points to 0. And if you have no records, right, then the pointer itself points to 0, right? Everybody, this is a perfectly good list. It contains 0 elements, right? And now we want to insert one node, right? So we want to do that. And then we insert more nodes, right? Everybody kind of follow that? Here's no nodes. We insert this node, and then now I guess, here's a question. Am I building a queue or a stack? It's a stack, right? Because who do I have access to? I have the access to the last element, right? So now we're actually doing something that we're supposed to do. We're supposed to, in this course, implement stacks, right? So now that's what we're doing. We're implementing a stack, all right? So we have to say, how do you insert a new guy, right? How do you insert a new guy? We have to write code for inserting a new guy, right? And so you want to write code that kind of always works. And we could talk about, well, how do you insert into the empty list? But that's a funny case. So let's think about a more generic case. I don't know how generic it is. It's a list of length 1, but right. Let's write the code for this. All right. So I said we're somehow starting there. I don't know why we don't. All right. So we're going to put right. So this is just, again, what this is saying, right? This is saying head in Java, head is either an object or a pointer to it, right? Head's a pointer to it. And you go into the element field and you put 1, right? And then we say head.next, right, is going to be null. And so what we put in there is null, right? And if you're wondering what null is, it's just the 0 whose type is not integer, the 0's type pointer to anything you want to point at, right? Everybody kind of follow that? All right, so now what we want to do is we want to build this next thing, right? So you can think about how we can do it. We make a new pointer temp, right? So that allocates the memory for temp. And then we have to make a new record, right? So when we make the new record, we do this. In Java, we say, we want a new node. And what does that do? It allocates memory for the new node, and it returns the pointer to it, right? Should I start slowing down? Are we getting into things that are harder? Or are we still, you guys okay? You okay? All right. And now we want temp to point at it, right? So temp is now going to point at the new node, right? And right, and you can do it all in one line, right? We allocate the memory for temp. We allocate memory for node. We put the value into temp, right? It's kind of like you're setting up the variable temp and you're giving it its initial value all in one line, right? That's used, right? And then we want to do that, put a 2 in there, right? So how do we do that? we say temp dot element, and we put a 2 in it, right? And then we want to point that up there, right? So we need to name where's the value that we want to move, right? We want this to point there. So we have to we got my green. Sometimes I might have my greens and my reds mixed up. Anyway, we want to name this box, right? How do you name this box? Oh yeah, with this, yeah. I think I might be switching my greens and my reds. Ignore greens versus reds, all right? We want to name this box. This box is temp.next, right? And what value do we want, right? The value we want is the 239, right? We want it to point at this object, so we want this value. Who's holding this value? Who's pointing at this now? Head is pointing at it, right? So we're going to take the value out of head, right? Right, that's the value that goes there. Who has that value, right? Head has that value. So we take the value out of head and we put it into this field, right? People see this? Now we get some nodding here. How are the rest of you? Is this code you feel comfortable writing? All right, we got some, nobody's nodding. I bet you some of you, would struggle with this. And if you struggle with it, that's reasonable, all right? Anybody want us to go over this code there again? Yeah, you have questions or? See what I mean? That was a brilliant question, and that's the sort of complication, right? Now, maybe maybe my picture is not good. So you never point to a field, all right? You always point to the whole record. So this is not pointing to the next field. And if you said head.next, you would get the value 0, right? Which is a good thing if you wanted to, right? If next was pointing at somebody, and you wanted this to point where this guy's pointing, then you would put head.next here, right? But we want this box to point to this record, right? And who is pointing at this record? Head is pointing at this record, right? So what we're saying is we want temp.next, which is this field, we want it to point the same place that head is pointing, right? You can say it in different ways. And I hope some of you at least agree that it's not trivial, right? It's a little complicated. Everybody good? All right. That sets the pointer. All right. That moves that value over there. And that sets this pointer to point there. And we're good. Right? So temp.next equals head says temp.next and head are now pointing at the same object, right? Temp.next is pointing there, head is pointing there, right? In terms of a mathematical statement, I mean, maybe that's one way to check it, is it's not a math statement, it's an assignment. But after you execute the assignment, it then should be true as a math statement, right? After you execute it, those two have the same value, they're pointing at the same thing, right? Right, so if we're doing it in, right, we could say they're not pointing at the same object, right? We could say they are the same object, right? If we're doing it in Java, right? Everybody good? Anybody actually read a Java book, and do they draw pictures of pointers, or do they? Right, how do they draw? They must draw linked lists as linked lists, right? So I don't know how they, yeah. All right, so now we want to do this, right? Because we're forming our linked list. So we want head now to point at the top of the stack. All right, so everybody think what's the code to get head to point there? Everybody think about it? Yeah, right? So again, what value, we want to change this, right? This is pointing there. So which box are we changing? We're changing this box. How do we name this box? Well, this box is simply head, right? And where do we want to point it? We want to point it here. Who's pointing there? Who has that value, right? Temp does, right? So we just say that, and we get it, right? All right, and that sets the pointer, right? Puts the value in there, sets this pointer rotating, and we're happy, right? So this code changed a list of length 1 into a list of length 2, right? So what are we going to do now? How do we make a list of length 3? We just go around, right? Right, write code to add a new list in front. Well, it's the same code, right? Everybody see that? It worked the first time. You can run through it again, and you'll see it works each time, right? And yeah, so you might have to check it, right? You should check it to make sure it's doing the right thing. Do we check it? What does this do? It allocates a new list pointed to by temp, right? What does this do? It goes temp.element, and it puts a 3 there, right? You notice I changed it to I, right? And then what does this line do? It says, right? It says temp.next. That's this box, right? Who do we want it to point to? We want to point to this record. Who's pointing at this record? Head's pointing at this record, right? So that's, everybody see that line? That's this line points up here, right? Then we said head equals temp. Well, it just takes the value that's in temp and point. What do we want? We want head to point down here. Who's pointing down here? Temp's pointing down here. We do this, and now they're both pointing there, right? And that gives us a linked list of length 3, right? And you do it again, right? And right? It's just, people following this code, right? All right, so we wrote the code for when we already had a node, right? And then we gotta write the code to put that first node in, right? And we haven't done that yet. And so one thing that's good to do, whenever you do have a loop list, a loop, you have sort of a loop invariant, which says what it looks like at the top of the loop, and then what it looks like when you come around has to be the same sort of thing. And you can see we have a loop invariant. The loop invariant is the top. We have this linked list, right? And when we go around, we make progress because we push somebody on the stack. We make the list a little longer, right? So you want to make sure that no matter what, if the loop invariant's true, it works, right? So now we have to think, well, what does the empty list look like? All right? The loop invariant says, I have a linked list. Well, is this a linked list? Yes, it's a linked list. It just has 0 elements. And 0 is a perfectly good number, right? Now, it's a funny one. Everybody's agreeing it's a funny list. And so it's not guaranteed that the same code works. But we might as well run it and see what happens. All right, so we're here. And so what do we do at the beginning? We allocated something for head. We said I equals 1. Oh, hopefully up there is, let's move this. Right? We make head and we make head null. Right? So that's what we set this up. Right? And if you believe, what I do is I'm all about loop invariance. Right? So you got to maintain your loop invariant and you got to establish your loop invariant. Right? So our loop invariant is that at the top of the loop, I have a linked list. And what does that code up there do? It sets up that. And I claim that's a linked list. So we've gotten our loop invariant, right? And then we're going to run our code, right? So where's our running? Oh, I moved things. All right, where's our running our code, right? What do? We set up the temp, the new guy, first guy, right? We store 1 there. What do? We get temp.next is going to point where? It's going to point where 0 is pointing. Where's 0 pointing? Pointing at null. So where's this going to point? It's going to point at null, right? All right, head equals temp, right? So now head's going to point the same place, right? And then we're at the top of the loop again. And what did we maintain the loop invariant? Right? Absolutely we did. We started with a loop of size 0, and the same code gave us a loop of size 1, a loop of size 2, a loop of size 3. Right? Everybody good? There's the same code in Python. I don't know, you got brackets, you got to deal with brackets. We don't really need to deal with Python. In Africa, they were doing Python. All right, so, all right, how much time do we got? We're still good? 23 minutes, we got lots of time. I just saw people rustle, so I was wondering. All right? All right, so now we have a linked list, and if you want to access the 1, how do you get there? Right? And this is an arbitrarily long list, right? So you can't just get there. The only way to get there is to walk, right? Somewhere there, walking on a linked list. You got to walk there, right? So we're going to have a new node called walk. And what is it going to do? It's going to start pointing there, right? And then what does walk equals walk.next do? It says, I want to change the value of walk. And what do I want to change it to? I want to change it to walk.next. What's walk.next doing? Well, it's pointing here. So now I want walk to point here, right? So what does this code do? It walks. Right? Everybody agree with that? And we put a loop around it, and it walks. Right? And when do we stop? Well, you got to decide when we stop. Right here, we're going to stop when walk.element equals 1. Right? Then we stop. Right? Everybody good with that? And what happens if we didn't stop? Right? If here we executed it 1 more time, then walk would have what value? Null, right? It would fall off the end of the list. It would have null, and you would have dropped off the list, right? And then that would have been fine. The code would have, everybody would have been happy, right? And then you do walk.next, and what would happen? Yeah, you would throw an error. You can't access nulls. All right. Right? So, right. So this is just saying I'm a big believer in proofs by picture, right? So it's kind of like, I'm going to be bringing in this idea of a loop invariant. The loop invariant is a picture. What's the picture in this case? I have a linked list and walk is pointing somewhere, right? So you get in your mind what that is. Generic linked list, walk is pointing somewhere. What does the code do? It makes progress while maintaining the loop. It's still pointing at somewhere, but it's pointing closer to you want to be, right? All right, so what are we doing now? We're getting a new node, and node 4. All right. Oh, yeah. So what's happening now with our picture? Here, what did I do? I just said head is pointing somewhere else. Yes. I think it's the same as an integer. Yes. Could it be point to somebody else? You mean it could point to... Yeah.
Because head has the same as integer value, opposed to the size of whatever element A is.
Yeah.
Try to write some code that changes head to some element different size of set B.
Yes. 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 Right. So in a strongly typed language, I think like Java, even though head is an integer, really is an integer, Java knows that it's of type pointer to node. And if you tried to point somebody else at it at somebody else, it would yell at you. Yes. Yeah. In Java, you say node head, and now head's of type, it is a node or it's a pointer to a node. Yes. Yes. Yes, absolutely. And in other languages like C, in Python, nobody's going to care. Right? All right, so what happens in my picture? Anybody panicking? Yeah, yeah. In fact, 2, 3, and 4 are unreachable, right? So if you have garbage collection, Java have a garbage collection, right? It's gonna garbage collect, right? We say it's dropped. In C, it's a data link. In Java, it garbage collects, right? People follow that? Nobody's pointing at it, right? That's pointing there. All right. Everybody good? Looks like we're going to do an excessively complicated example. All right. Right. So the right-hand side equals, right, is head. And then we say head.next. Where's head.next? It's there, right? Right. So the left-hand side, the other side, we got head. We got head.next is there. We got head.next.next is there, right? We put an equal sign in, right? Now, everybody think what this code's going to do, right? It takes the value in head.next, which is this guy, and it puts it in here. So where's this going to point? It's going to point there. Right? Everybody see that? So you can see you do have to think about this. You do have to trace it out and think, which box is this naming? right? Which box is this naming? Take the value out of the one box and put the value in the other box, right? All right, so this is our walking routine. Where was I? Oh, I see. I went. Where are we? I don't know where we are now. Oh, we went to the very end. That's where we went. I hit the end button. Building a linked list, walking. Right, this is where we are. All right. All right, so now we're just gonna run this code, right? Just for fun. Why? Because we're bored, right? You run this code, and what's gonna do? Walk is gonna point where head's pointing, right? Here we get walk pointing where head's pointing, and now walk is gonna point where walk.next is pointing, right? So you're gonna walk, right? Now what's this code gonna do? Walk's gonna point where walk.next is pointing, right? So what's it gonna do? It's gonna walk forever. Everybody kind of follow that? You want to write code that goes forever? There's code that goes forever, right? All right, what are we doing now? We got a node. Right, so here we declared the thing. We made a new node. There's our new node. If you want to execute some code as the node is being created, all right? So here we're giving new node, we're giving it passing it a value, right? So in here, we can, within node, right? Node can both have elements and can have routines. And if you call a routine the same as the name of the object, then when you call node to create it, you execute that code, right? So here the code says, what do I take in? I take an integer in. What do I do with my the variable initial that I'm passed in? I stored it in element, right? Now, note here, I'm not saying dot element, right? It's just element. And that's kind of a funny thing, but it's because I'm inside of the code, right? I'm inside of the node. So inside of the node, this field is just element. And so it's called element because that's what it's called, right? Everybody kind of see that? You have to sometimes you have to know who you're talking about, and right, we're talking about our local, the one we're creating. What does this do is the element in the node that we're currently creating is going to have its element field contain the initial value, right? So as we create it, we put a 5 in there. Yeah? So what does this do? This says, I'm going to have more than one routine called node. How do we differentiate them? Is what we pass them. This one, we're passing nothing. And what are we going to do when you call the routine that's passed nothing? In this case, we do nothing, right? And I think you probably, I don't know, if you didn't have that line and you called node without anything, it might crash or it might figure it out. I don't know. What? It's still all right. So maybe you don't need to put that in, but it's good to know that you could put it in, right? Right. This is called the constructor, and which constructor gets executed depends on which one how you're doing it, right? So if you call that, then 0 gets copied in. And do zeros get copied in? In C, when you construct an object, what's there is whatever happened to be there when you, in memory, when you called it.